the chart. So many of you have already seen this chart. So when we look at conducting job hazard analyses or even facility inspections or job site inspections, sorry, admitting people along the way, we want to identify those hazards, but then walk through this hierarchy of controls. And the first step we want to look at is we've identified a flying object hazard as an example. Well, we just don't want to hand out safety glasses. We want to look to see if we can enclose a piece of equipment, use a different piece of equipment, or maybe subcontract out a portion of our operation and eliminate a hazard. So removing the hazard overall so we don't have to deal with it, it doesn't exist anymore. So elimination, sometimes elimination is extremely difficult. So let's say we can't do that. Let's step down to the next block. Let's substitute it out. Let's say we have a solvent, an unfriendly solvent, MEK. MEK got a bad rap for years. I think its reputation has improved slightly over the years, but it's not known as the friendly solvent. But maybe we're using MEK as a solvent, and in our processes, we've determined, we've done some tests, and maybe we can switch over to acetone. Acetone is a little bit more friendly solvent than MEK, has higher permissible exposure limits, things we talked about last week in respiratory protection, and we substitute out a product for a less toxic substance, let's say. So that's substitution. Okay, so we can't substitute out. Can we engineer out a control? Engineering out a control, let's say somebody has an elevated location. Many of you might have like a warehouse operation, and there's a shipping office or a warehouse office out in the warehouse. And we have some stored products on top of this office in the warehouse. Well, if I'm Cal Ocean, I walk out in the warehouse and I look on the office and I see some boxes, maybe some documentation. I'm going to say, does any employee ever go up to that elevated location? Maybe they get an A-frame ladder or an extension ladder and climb up there and go onto that elevated location. Well, we have a fall hazard if they do. In California, it's 4 feet in a general industry setting. So anything over 4 feet, we're gonna have to protect it. So what can we do about that? We can remove all those objects from that location, or we could put a guardrail system in with maybe a fixed ladder we're gonna install on the side of this structure, and we're gonna put a gate at the ladderway opening. That's engineering. That's engineering out that particular hazard. We can't eliminate it because we can't take the products down. They have to stay up there. We have limited space, so we're going to protect the employees from the fall hazard by a compliant guardrail. The fourth step or control that we can consider if the top 3 don't work, and these are in order of priority, by the way, I didn't say that, are administrative controls. Administrative controls are things like employee rotation. Say we have a loud work environment in one section of our building. We'll say section A of our building is very loud. Section B of our building is very, very quiet. Well, can we rotate employees? Can we cross-train them? Can we move employees from section A to section B halfway through the workday, which lowers their noise exposure? Because in the future, we'll probably have a hearing conservation or ear protection webinar, and it talks to what our action levels are and our permissible exposure limits are as it relates to noise. So administrative control would be rotating an employee from one loud environment. We had a plastics recycler that had this exact situation where we had the grinding machine, very, very loud. They considered cross-training and rotating people out of that area into a quiet area. And when we conducted noise dosimetry testing, we got those employees' exposures below 85 decibels average over an 8-hour work shift, which took away the requirement for a hearing conservation program. Not necessarily taking away hearing protection away from employees, but at least eliminating some of those requirements on the hearing conservation standard. So we have these first 4 steps: elimination, substitution, engineering controls, administrative controls. We've evaluated them for feasibility and practicality. And we've documented that they don't work for us. We can't rotate employees because they're specialized employees and it takes a long time to get them trained. It's not practical. We can't engineer it to hazard. We can't substitute the chemical because no other chemicals work, and we can't eliminate. Then we're at personal protective equipment. Last chance for gas. And the reason is when we have personal protective equipment, we're relying on equipment, but we're mostly relying on the employee, the human being, to wear the PPE when it's required, care for the PPE, use the PPE appropriately, those kinds of things. So now we're bringing in the human element, which obviously causes problems. If we were robots, probably wouldn't be an issue. Or the robot is the elimination of the hazard, maybe. We go back up to step one, but human beings are the weak link when it comes to safety.